DIY Pulse Oximeter. Assembling controller. Hey guys, it's DIY Pulse Oximeter I developed. There are several types of modules for pulse oximeters available from online shops. But now the world is confused by COVID-19, and the availability of those modules is not good. So I developed a pulse oximeter which used cheap and general electric parts instead of dedicated module. In this video, I will show you how to assemble the controller part. Okay, let's get started. First, introduction. I will show you the schematic. You can download the schematic, board data, parts list and others from my website. The circuit operation will be introduced in another video. The amplification circuit part of the phototransistor will be embedded in the probe, so it is not included in the main board. I prepared two kind of main boards. Model A is a type in which the microcontroller part is wired separately. It can be used when you want to design the case yourself or when using a microcontroller which is not Arduino Nano. Model B is a type that can mount Arduino Nano. I prepared an original case for Model B. In addition, all parts can be aligned with THT parts, so you can also assemble using the universal board. In this video, I'll use Model B. Second, assembling PCB. Refer to the schematic and the parts list and solder the parts. Solder lowest parts first. This PCB uses 1/4 of a watt resistors, but most resistors handle small signals. If you want to use a universal board, 1/8 of a watt is okay except for RRED1 and RIOR1. This op-amp handles signals near 0 volts. Use a single supply type. LM358 is recommended. NPN transistors support TCB and DBC pin assignments. NMOS transistor supports SDG and SGD pin assignments. Please mount according to the parts you have. Make 3 volts with this LED. If you mount the CP2 vertically, it will interfere with the case. Mount it horizontally as shown in this video. SW2 is optional. It has no function in the default program. Mount an Arduino Nano or compatible. Cut long pin headers as they interfere. RIOR1, RRED1, RL1 and RT1 need to be adjusted according to the brightness of LEDs. Temporarily solder the parts list initial values to the pads. Since the former two resistors flow large current and the latter two are easily affected by noise, we adopted cut and try instead of a variable resistor. Finished. Third, wiring. Wire the probe and LCD to the main board. The assembly of the probe is introduced in another video. Solder the probe wiring to the back side of the main board if you want to put it in a case which you can download from my site. probe has 6 wires. Use the I2C1602 type LCD. You can use pin headers and jumper wires, but this time I soldered them directly. Finished. Fourth, resistance adjustment. Adjust resistances according to the brightness of the LED and HFE of the transistor. The program has already been written to Arduino. Power on the main board and press and hold SW1 for about 5 seconds during boot. Press SW1 to select adjust resistor. Press and hold SW1 to confirm. Numbers from 0 to 100 are displayed for each of IR and red. Adjust resistances so that each values are about 30 to 40 when you wear the probe to your finger. Increasing RIR1 or RED1 and RT1 will increase the display value, and increasing RL1 will decrease the display value. At first, adjust RT1 so that the larger of the two displayed values is about 30 to 40. If the adjustment width does not fit within the RT1 range, adjust RL1 as well. In this video, I'm working with the power on, but I recommend turning it off when changing the resistor. It's still small. Okay. Next, increase RIR1 or RED1 with the smaller one, and adjust so that the displayed value is about 30 to 40. Since the red value was small this time, adjust RRED1. This board is not connected to the test pads of RIR1 and RRED1 due to the pattern error. So I solder directly to the through hole. The downloadable board are fixed this problem. When both values are about 30 to 40, the resistance adjustment is completed. OK. Push SW1 to reset. You can already measure SpO2. Solder the adjusted resistance to the through hole. Finish. Fifth, casing. Download the STL file for the case from my site and print it on your 3D printer. Tap the threaded holes. All screws are N3/5 mm. Thread the probe wire through the groove on the bottom of the case. Fix the board with screws. Since the LED interferes, bend it slightly inward. tap the threaded holes to attach the LCD. Fix the holes for the screws with a 3mm drill. Remove the USB hole supporter. Cut off the LCD pin header as it interferes. Fix the LCD with screws. Finally, close the case. It's the end. Thank you for watching. Do you want to try this DIY pulse oximeter? More information is available on my webpage and this channel. Please subscribe me.